Okay, so here we go. So we're going to do number 11 here. 11. The interval was from 0.169 to 0.143. And we want to put this in a form that looks like this, right? This is what we're trying to do, right? We're trying to put this in a form like this. So to find, what I'm trying to find, this guy is in the middle, right? Because this guy plus or minus the same amount. So it's smack dab in the middle. So I have to find the middle. So I'm going to add the two. 9951 that. I'm going to divide this by 2. Correct? If I divide this by 2, I'm going to get 0.07599. It looks like something like this. 995. 995. Thank you. Okay. So this is the middle point. This is this guy. Right? To go from here to the top line would be plus E. If I go from here and I subtract the error amount, it would be that. There's two ways I can find. Yeah, what?
I just read the question wrong.
Oh, okay. You had the point.
Well, I didn't. For some reason, I thought it said P had plus or minus E, not just minus E.
Yeah.
Okay, well, minus E would have been this guy.
No, yeah.
Plus E. We're good?
Yeah.
Okay. All right. Okay, so let's move on. We were at page 305. Ready to do 307. No, we're not ready to do 307. We're ready to do 303. So we're on page 303, page 303. The margin of error, we did not learn this yet. So we said it was going to be P hat plus or minus E. Where do I get this? This I get from the sample, correct?
Yes.
I get from the sample I took, I don't know, if there was like 25 out of 75, then this would have been 0.33 repeating or whatever, 1/3, right? And then you would do plus or minus E. This part we did not know yet. Okay, so yesterday we learned about the critical value. I gave you 3 of those, right? When it was 5%, 10%, and 1%. Okay? And then we are going to add this guy. So this here represents my error. So the error, E, is going to be equal to the critical value that we learned yesterday, PQN, where N would be what? N would be our sample size that we took, right? So this is not large N, this is the small N, right? Because large N traditionally would have been the population size. We're not worried about the population, we're talking about the sample size here. P, what you got here, this Q would be 1 minus P, right? So it's 1 minus that. So in this instance, if I did, so it was out of this, right? What would my sample size be? Wouldn't it be 75, right? It would have been 75. So it would have been 75, 1/3 times 2/3. Everybody understand where the 2/3 come from? 1 minus 1/3 is 2/3, right? Because P plus Q is equal to 1. P 1 minus Q, or Q 1 minus P. P here was 1/3. 1/3, 2/3 all day, right? Okay? So that's how you would calculate this portion. This guy you would find, because I gave you the significance level of 95%, 90%, 99%, or whatever it may be. Yes?
Well, in the formula it says Z, and what does the fraction say at the top? The fraction one? The
This is alpha divided by 2.
Alpha divided by 2.
Alpha divided by 2. Okay. So that's on page 303, middle of the formula, 7-1. The error of error is equal to the critical value, z of alpha divided by 2 times the square root of pq divided by n. Okay, so if you go down to the very bottom of page 303, it kind of all puts it together in a nutshell for you. And it says the objective, construct a confidence interval using the estimate, use it to estimate a population proportion. Okay, and then there's the notations, requirements. The 3 things, right? We said the 3 things. Okay, we have to have a simple random sample, and NP has to be greater than or equal to 5. What was that called? I told you it's called the large counts. This is called the large counts requirement. The large counts requirement is 5 here, and I also told you that in some books it is 10. Okay, this book is 5. Okay, and then there's another one here. We're not too worried about that, but we would do one because we want to make sure it is a binomial, because we're taking a binomial and we are saying that it's normal, right? We're going from binomial to normal. Okay. One thing that's not here that should be here is that you may not oversample, right? You cannot sample more than 10% of the entire population. Okay. 3 requirements. SRS, simple random sample, you cannot sample more than 10%, and large counts. Okay? All right? Those are the 3 requirements that you need to check. And if those are all checked out, then you can now construct the confidence interval using that equation, and we're good. We're good. Okay, so flip the page, go to page 304. So it gives you a procedure there. Okay, so let's not worry about the procedure right now. Let's go and see if we can just jump right into example number 3, and we'll see how this goes. In the chapter problem, we noted that a Gallup poll of 1,487 adults showed that 43% of the respondents have a Facebook account or Facebook pages. The sampling results are n is equal to that, p is equal to that. A, find the margin of error that corresponds to a 95% confidence level. So we're doing a 95% confidence level. 95% confidence level. Therefore, my z is what? Does anybody remember what the 95% was?
1.96.
1.96, correct? 1.96. So 1.96. So my error is the z alpha divided by 2 square root of pq over n. So I have 1.96 for my z value. All right, 1.96 square root of, what was p? 43%. So 0.43 times q is 1 minus 0.43. So what is that, Isaac? 1 minus 0.43.
Oh, well,
0.57. Yeah, good answer. 0.57. Correct. And the sample size, 1487. Okay? All right. And yes?
I got lost with the z-score.
The z-score. Okay, z-score, if you go to page 302, bottom of page 302.
Oh.
See that?
Yes.
Okay, we did those yesterday. We did the inverse norm. right? We did the inverse norm to find those. Okay. Okay, B, find the 95% confidence level, and so the confidence level itself is going to be what? 0.43 plus or minus this guy here, right? Does that make sense? Okay, by the way, if I do this, the book says I'm going to get 0.025, 0.025, 0.025. Therefore, the confidence interval itself is 0.455 and 0.405. So this will be my confidence interval, right? From here to here. And the question that is always going to be there is the conclude. How do we conclude? I told you there was very specific language here, right? What was the language?
I'm pretty sure it's in between.
We conclude, right? We are 95% confident that the interval 0.0405 to 0.435 contains the true proportion of the people who have a Facebook page. Okay? Very specific. We are 95% confident that this interval contains the true proportion of people who have a Facebook account. Okay? And good there, we're good there. 3, I am supposed to finish up to 306, 305. We did there, 306. Okay, so on the bottom of 305 it says, analyzing polls. Example 3 deals with a typical poll that we just did here, right? When analyzing results from the polls, consider the following. Number 1, the sample should be a simple random sample. 2, the confidence level should be provided. And you always want to know what the alpha is, right? Okay. Always want to know what that the 95% or 90% or 99%. Then 3, the sample size should be provided, n. Right? Then 4, except for relatively rare cases, the quality of the poll results depend on the sampling method and the size. Okay, but the size of the population is usually not a factor, right? When does it become a factor? Oops, where'd it go? I cannot oversample, right? I can't. That's the only time when it comes into play. Okay? So if you were going to do a sample of students of Blanchette, what was the highest number that you can sample?
27.
20.
If you want to do just the high school, it's about 27.
Oh, wait,
If you want to do the whole school,
Oh.
it's 400, right? Basically 400, right? So 40, right? So you can't go over 40, okay? This will come into play when you do your second half, your project. We'll do a project, okay? And then you're going to have to do a sample. You can't sample more, depending on what you're doing, right? If you're going to sample just the seniors, what's the most you can sample? 4, right? Like 39 of you, or how many are there? 36? 3. Okay, all right. Okay, so that's that. Flip the page. That was that. We flip the page. Okay, blah, 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 blah. Find it. Okay, we're good there. Okay, everybody read. I'm not gonna go over this. Go in the middle. There's a how to find the p hat and how to find the margin of error. You just did this. You were doing number 9 through 12, right? Verify that. Verify that makes sense.
What page?
Page 306. Page 306. Does that make sense? Given the confidence interval, you just add the lower and the upper confidence level and the lower confidence interval, and you divide it by 2 to find the middle point, and to find the margin of error, we just from the upper you subtract that. Okay? We good? All right. So I'm good for the day. Or your homework for today is 13 through 24. 13 through 24. 13 through 24. Let's work on that.